Hello again. This is the course of data structure and algorithms in industrial and management engineering department. So we already deal with the basic data structures like the array and stack. And today I'm going to explain about queue. So what is queue? The concept of queue. And as I mentioned to you previously, one of the literature that I would like to use for this course is from the book Data Structures and Algorithms in Python, written by Goodrich, Tamasya, and Goldwasser. So I took this slide from the book, and yeah, if you want to review the materials again, you can just check from the books. Today I'm going to explain about the QADD. I already explained what is ADD in the previous lecture, and array-based queue and queue operations. Okay, so let's take a look on QADD. We call ADD as the abstract data type. Do you still remember about it? Yeah. So the abstract data type, when you deal with the stack, okay. So stack is also one of the ADD that you can use to develop some other applications, and queue is also one of the ADD that you can use to deal with uh, applications. For example, if in the stack you use the concept of last in first out, okay, just if you still remember that one, last in first out, because you will do the stacking. So the last item, it will go out at the first time, but in the queue is a little bit different. So we are using the first in first out scheme. Sorry. So the insertion and the deletions in this queue is using the first in first out, and the insertion at the rear of the queue. It means rear means at the end of the queue, and the removals are at the front of the queue. So once, okay, for example, you go to the bank, and then if you are in the first queue, yeah, so you will go to the teller, and then it goes to the next queue, and the next person after you will be the second, the next person after the second person will be the third person, and so on. So the main queue operations, there are two. The first is enqueue, and we have one parameter, which is the object. It means I would like to insert an element at the end of the queue. The other operation is dequeue. When we do the dequeue, it means we want to remove the object from the queue, and we want to return the elements at the front of the queue. So there are three other queue operations. We call it the auxiliary queue operations. As you might know, in the stack we have also those three queue operations, but the queue operations have different auxiliary operations. They are first, length, and is empty. In the stack you have top, length, and it's empty. So the only difference is about the first. In the queue, we want to know which item or what item is in the first element, or what item is in the front, and we will not remove it. The other auxiliary queue operation is length. We want to know how many elements are there in the queue, and also we want to check whether it is empty or not. So if there is a list or there is a queue, so we want to check, is there any element inside the queue or not. There's one exception. If you are trying to dequeue, okay, then we want to check if the front there is an element or not. If there is no element, then it will go to empty queue exception. So let's check this one. We have the operation, okay, and then we want to do this step by step. So these are the operation. I think you already know from the previous example with the stack. So we also have the same step, or we have the same operation. Okay, so let's suppose we have the queue, okay, and the queue start with the empty. Okay, it start with the empty list, and because it is started with empty, then we will do the enqueue. We have one object to enter, which is 5. So the list will have 5. And then we want to insert another object, which is 3. Then now we have 5 and 3. Okay, maybe I can just type this is on 5 at the first time, and then after I have 5, and then next is I have 5. And because enqueues concept is we want to add the element at the rear part, so this element 3 will be added in the rear part. We want to check the length, so the length equals to 2 because we have 1 and 2. Okay, so the result is 2. And then we want to dequeue. So what is dequeue? We want to remove. Then if we are dealing with the stack, you will remove the last element, but we are using queue, so the dequeue will remove the first element. So the return value, which is 5, will be deleted. So the remaining value will be 3. And you want to check if queue is empty or not. Because queue still has one element, then of course it is false. We want to check, we want to do another operation, which is dequeue. So the element remain in the list is 3, so we will just remove 3, and the next we will have empty element. Okay, so this empty element, and we want to check, is empty? Yes, it is true because nothing. Okay, and you want to dequeue, again the result will be error. Why? Because we have no element in the list. And next we want to enqueue, so we want to insert 7, so we have 7. And if we have another enqueue, we want to insert 9, then we have 7 and 9. Okay, so 9 will be inserted at the end of the list. I want to check what is the first element. So the first element is 7. Okay, now the first element is 7, so it will return 7. Next, I would like to enqueue 4. So another object will be added. So we will have 7 and then 9 and then 4. Okay, so there will be 3 items. So if you do with the length queue, then it will be 3. And after you have those, I would like to enqueue. So the enqueue will be returning the value 7 because 7 is in the first, and then the remaining will be 9 and 4. Okay, okay, so using this operation, you know, okay, the result step by step. The application of the queue, so the direct application will be the waiting list. Okay, I guess you know, if you are going to bank or if you are going to the government office, some bureaucracy needs this kind of queue. So who comes first, it will give the first service. And access to shared resources. So for example, if you want to print, okay, you want to print multiple documents, then it will start with the first, and then it will go to the next, it will go to the next, and so on. The same with the multiple programming. Okay, when you have the multi-programming, it means when you start with Microsoft Word, and then you start with Microsoft PowerPoint, and then you start with Microsoft Excel, then yeah, it will be on the queue. If you start the Word first, then the next item or the next program or the next software will be the next, or will be the second, not the first one. The indirect application, it can be for the auxiliary data structure for algorithms. Yeah, you know the data structures. This is also on one data structures. And in other application, you can combine stack and queue. And the queue as well, it can be the component of other data structures. So you can combine, like in, for example, in the binary tree later, yeah, we will learn how about the sorting. Yeah, you can also insert with the queue. One concept that you may need to understand is how we deal with the array-based queue. So array is, we already learned one section about array-based sequence, and in the array-based sequence, if we use the traditional array, there is a limitation on the size. So if we have limitation on the size, it means we need to consider when the array is full. Okay, when the array is full, what will you do with the queue? So we have we use an array of size n. We can use what we call as the circular fashion. What is circular fashion? So in the normal configuration, okay, let's say I have two variables. I can say f and I can say r. Okay. What is f? F is the index of the front element, and r is the index in which you pass the rear element. So if we have a new element, it will be stored here. So this will be the last element. Okay. Now I want to have the array location r is kept. Okay, so I want to just keep this one, this location. So for the normal configuration, we have like this one. F is the front. Maybe this element, this element, and this element, and this element, they already finished with the service. So the pink color will be the element on the queue. Okay. So it is the elements in the queue. And if we are making this, let's say I have new element here, I have a new element here, and I have a new element here. What happens if there is a new element? Because we don't have any space in this space, okay? Because there is no space, so I need to put in the first element or in the first location, in the first index, because it is empty. Okay, and then I will put here, and then I will put here, and then I will put here. Okay, let's assume that now this one has been so they already go, so they remove from the location. Then you can put this as blank, and then yeah, we call this one as the circular fashion, or with the wrap around configuration. So the F will go to the rear part, and the R, if it is full, it will go to the front part. Okay, so this will be the wrap around configuration. Now the size, it can be different. If you are using the length, you can just notice about the number of elements in the list. But for the size, it will be different if you are using the circular fashion or wrap-based configuration. Now let's see if you have this size, n will be subtract by f plus r, and then we have mod n. How can I say this one? Let's say this one. Okay. So let's see if we have this queue. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. So I would like to make a new, let's see, I want to make it a new, so n equals to 17. Okay. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18. Oh, sorry. Huh? Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. And I want to have the f. What is f? So f actually it is the index. It is the index of 4. Okay. And then what about the r? Okay. So the r is the index is, let's say this is 17, okay, 16 and 15. So I can say this is the index of 14. Okay, you can check 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now using this formula, what is the formula? You can have the 17 minus f, which is 4, plus 14. Okay, the result will be 13 plus 14. 13 plus 14, then it will be 27. Okay, so 27 mod. Okay, so we have 27. It will be modulo or remainder of the division with 17. Then the result will be, yeah, the result will be 10. Am I right? Okay, so there will be 10 elements. So the size that is now in the queue, there are 10. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the way to calculate the size. Now, if we have this queue, so the n is the same. Okay, so the n is the same, but the f is different. Now, f, what is f? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So f is 11. And then what about the r? R is 4. Okay. So using the same way, we want to calculate the size. So we have 17 minus f, which is 11, plus r. R is 4. Then the result will be 17 minus 11, then you will get 6. 6 plus 4, it will be 10. Okay, so we want to check whether more 10 mod 17. What is the result? Yeah, yeah, the number can be divided by with 17, and the remainder will be 10. So it will be always 10. Okay, so this is 10. Now let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 elements in the queue operations. So all the pink element are the queue with the element, and whenever the f is changing and the r is changing, we don't care about the numbers, because using the formula we can still get the size or the number of elements in the queue. So when you do with the NQ, so we want to ensure that the operation NQ throws an exception if the array is full. It means you cannot fill again the queue when there is no space in the array. So the NQO, it means if the size equals to n minus 1, then we will throw full queue exception. So if the size is already the same with n minus 1, then exception. Otherwise, we will do the QR. Okay, let's put the object O in the R position. So R, it means the last one. Okay, and then R will be equal to the R plus 1 mod n. Oh, what is it? Okay, so we will keep updating the R according to the n number. So let's see if it is here. So we have 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So the same with this one, I guess, and the same with this one. Yeah. Now I would like to know the R operation. So with the R operation, we have the R equals to R plus 1 mod n. So the R plus 1, it is from the R which is 14, so it means 15 mod n. Okay, because R is 14 and plus 1, then we will get the 15 mod 17, then the result will be 15. Okay, so we want to go to the index 15 once you finish to insert the element O here. Okay, and what about this one? So if we have the R equals to 4, then you will do the same equation. So the element here will have like 4. Okay, after you have the index 4, after you insert index 4 with O, then you will do the addition. 4 plus 1, it means 5. 5 mod 17, then the result will be 5. And it means you will add the elements in the index 5 if there is another NQ operation. Okay. Now you can also do the same thing with the DQ. If the DQ operation exists when the queue is empty, then it should go to the exception. If the DQ and if it is empty, let's throw empty queue exception. And then the exception is specified in the QADT. Yeah, like this one, we have the same. The O, it means the object, it will be the QF. Okay, F is the index. And then when you want to remove, okay, you want to remove the object, so just check the F, the index F, and once you know the index F, you will remove the O and you will just return the O. But don't forget to move the front. Once you already remove this one, okay, if you remove this F, if you already remove this F, of course, this element will disappear and the new F will be here. Okay, so this will be the new F. So that's why we will do the F plus 1 mod n. It's the same with this one. If I remove this element, then I will just remove this one and then the new F will be here. Okay. So we can do the queue in Python. Okay. So in some code, they use the underbar data. Underbar data means they use the variable to indicate the fixed capacity and the size. So the size is representing the number of elements stored in the queue, and front, it is the index that you are now you have the element that you want to remove at the first time. Okay, and you have the front, it is assumed that your queue is not empty. Okay, I go to the queue. Okay, so in the queue, you can check the array queue. So using this array queue, it is the FIFO queue using the Python list. We have the init, it is for the constructor. You see here are 3, which is data and size and front. And then the length is to check the number of elements in the queue, and then it's empty. You know this one first, and then the queue. Okay, and the queue and resize. Oh, what is resize? So in the resize, you want to increase the array, but I guess it depends on what you're going to check. Okay, So if you still remember, there are two strategies to resize the element. You can do with the doubling strategy or the incremental strategy. So you already learn those things in the array. So you just run this one. Okay, after you run this, and then yeah, this is the example that I gave to you in the PPT. So first, just create the array queue, and then you can do q5, q3, and then find the length, and then the queue is empty, and so on until you want to take queue. So the result in the queue is just showing every time you do the operations, but you don't know what is the existing queue. So maybe if you want to check, you can check the queue. Okay, you cannot see this one. If you want to check, then you can see the data. Okay, so this data here. Now you can see here there are two elements, which is 9 and 4, and the location of 9 and 4 is in the 1 2 3 4 in index 4. Okay. One application for this queue is the round robin schedulers. So the idea is the same with the circular queue, or the what we call as the web-based configuration. At the previous slide, we already learned before. So the round robin scheduler is one of the application that is this kind of concept. So if we have a queue and we want to take queue one item, then the take queue will go to the share service. It means the element will be served, and after they finish the service, then it will be in the queue anymore, and it will be in the queue again, and it will raise the new enqueue. Okay, so for example, if E equals to dq, yeah, so we remove the element, and then we want to service the element E, and then after we service the element E, we want to enqueue again to this one. So it is a kind of the repetition, okay? Or yeah, we in the application we call it this is as the round robin schedulers. Okay, I guess I will stop here. So these are about the queue, and then array-based queue, and some application, one application about the round robin scheduler. So I hope that you understand at least basic concept about array, stack, and queue. So in the next video, we will learn other kind of data structure, and yeah, you will understand how to apply those in some very simple application. Okay, so please check on the e-class, and if you have any issues with the Jupyter Notebook, or if you have any issues with your assignment, everything, just let me know by email. Thank you very much for listening.